Today, my presentation is titled Vision to the Quantum Internet. So now looking back at the history, the current computer is based on the semiconductors, and then the internet emerged and all the computers were connected and data has accumulated. And various data has accumulated on the internet, and now AI is being developed. And now we are at the turning point. We are moving on to the quantum computer era. So the data has been analyzed using AI, but now quantum computer can do more. And then the quantum computer and network of quantum computers will be emerging in the future. To introduce myself, I am researching on the quantum computer based on the information technology, and currently I am interested in quantum internet and distributed quantum computers, and co-innovation is my interest. Quantum computer area and also Moonshot program, the national program, is where I am working as a project manager, and also wide project, the Internet Consortium, which was formed in the 1980s, started the Internet of Japan, and I am also working here. And quantum computing related consortium is another organization where I'm working with enterprises and academic scholars on quantum computing. And Quantum Internet Task Force is run by younger researchers, and what we have learned is that there are various layers, physical layers, networking layers, PCI-PC, the internet-related layers, and distributed processing layer and application processing layer. So there are various layers. I apologize, there are some mistakes on the illustration, but so we have a lot of human resources in physical layers, but when it comes to platform and application layers, we need to recruit more members. That was the beginning of this organization. So the research that we are conducting, I can talk about that today. However, each of them is quite difficult to understand. So today I would like to focus on the overview of quantum internet today. RFC 9340 is quite interested. PCI-PC, this is ITF, the standards for the internet, and the IRTF is the Internet Research Task Force, which is focusing on the research on the internet, and the quantum internet related document was for the first time approved. So the principle for the designing quantum internet was discussed here. So not only the quantum is specialists, but the classical computer network experts are also involved in this discussion. So we formed this document with that objective, and from Japan, myself, and Professor Bamida from Keio University and other colleagues from the US, they all authored this document together. So the internet, quantum internet is currently gathering interest and attention. And quantum internet means that using quantum data, we can connect any 2 points on Earth. Having said that, quantum internet mechanism is not present. It is only limited in the physics area. However, in the 2010s, the mechanism for a quantum internet and quantum network started to be created. So quantum data is transmitted, which means that the quantum internet will not be replacing the ordinary internet. They are both different. And this area is now gathering attention. IEEE is the communication standard creating organization. Ethernet and other cables and other standards that are used for classical internet are also established by this organization. And our research was praised by this organization and awarded Best Paper Award. So the engineering area is now currently focusing on the quantum internet. IETF is the organization that's established RFC, and in March this year there was a conference in Yokohama, and we hosted a lab tour and also showed the labs where we are now making the prototypes. So those network specialists who are novices in quantum area accounted for about 10% of the members and attendees of this conference, and they came to our lab, so it showed and demonstrated their interest. Now, looking at the quantum internet, looking at the current world, we are connecting the digital internet, and quantum internet is trying to emulate that. So quantum sensors and each of the quantum sensors can be connected to transmit the quantum data, or the quantum sensing network can be formed in other ways as well. The classical internet that you are using can also use the quantum interface network card and then transmit the quantum data as well. So there are different ways, and quantum electronic data transmission will be enabled by quantum internet. So there are some buzzwords in this slide: quantum Bitcoin, and also quantum secure quantum computation is also important. So it's just like a supercomputer today. A supercomputer is just the aggregation of many computers, and quantum internet can do the same thing. And also, very long baseline radio telescope is another example that will be enabled. So what we are trying to do is to form an infrastructure, and what business impacts are there. Today, the internet uses digital technology, and the market is expanding. So quantum internet will be cultivating into that by connecting the quantum sensors. So the quantum internet will be pushing the envelope of quantum field, and then theoretically we will be making that secure as well. So the security will be enhanced by replacing some part of the traditional internet. What are now taking place around the world? So the key words are testbeds in quantum internet, and testbeds were first formed in EU, Quantum Horizon, Quantum Internet Alliance project, started in 2018, which connected 4 cities. That was the aim. However, due to the COVID, the 4 cities have not been connected in this project yet, but quantum relay connection, POC, was successful, so the outcome has been yielded, and project budget was updated to about 3.5 billion yen in 3.5 years. So that was this information was published, and the Tokyo location and quantum centers will be connected in this project. So the EU-wide project is taking place, and also Germany is also investing a lot in the quantum-related project. In the US, up until 2020, the US was not very active in quantum internet, but in 2020, a series of events took place, and an energy Department of Energy and ESCF started allocating budget to this area. So that is quantum network related projects. So about $100 million worth of budget, including long distance quantum connection as well. In Japan, in terms of projects, we have national projects, Moonshot project, to connect the quantum computers to create distributed quantum network. So quantum internet related project has started. I'm involved in that as well. And QITF, our strength is that there is a diversity including a very long baseline radio telescope as well. So I'm sure that you are aware today, but there are various different types, and we are covering many of them. So we want to connect a lot of things using quantum internet, and since we have diversity of these items, it will be quite easy for us to achieve that in Japan. So I have been in information technology area, so we want to form a big infrastructure. So the information technology related expertise is now being utilized in this quantum internet project. So that is another strength that we have in Japan. And also the areas that are needed. As I said, we have a lot of layers. We have many experts in a physical layer area, however, not in application layer. However, having said that, we still have many talents in most of the areas, so we can expand our activities. I hope you will be also involved as well. So that is another strength as well. And we are leveraging these strengths in these projects. So this is the slide on a use case, end-to-end quantum key delivery. I can talk about the mechanism, but maybe I should focus on what's interesting about this. So RSA may be broken using quantum computing. Some people are talking about that. The reason is because the key delivery today is because the information necessary to disencrypt the key is still already in the internet. However, it will take more than 10,000 years to disencrypt the key. On the other hand, on the quantum internet, the necessary information will not be on the internet. That's why the key is quite secure. So the level of security is different between the traditional internet and the quantum internet. So this is blind quantum computation. On the server, data security, how is it ensured? You might be wondering. On the server, encrypted data can be computed using the current server, but overhead is too big. So realistically speaking, it's quite difficult. When it comes to quantum internet, the blind computation related overhead is quite small. So in the quantum internet, on the quantum server, quantum computation takes place. So overhead is very small, so it's encoded. And then even the administrator of the server can know what kind of information is used for the computation. So the program is disclosed to programmers, but using quantum internet, even the programming itself is concealed. So that's quite interesting. What this is good for is, maybe you are aware through some news recently, but for example, the person who holds your data may not be trustworthy. So the personal information may leak. That's because the data is not encrypted. So data security is currently based on the contract. However, so even the people with malicious intent can look at the data. However, using the quantum data and quantum internet technology, we can ensure the security of data through the quantum technology at the server. So a Byzantine problem and distributed processing. In many cases, we need to have consensus among servers. For example, we have distributed processes at the different locations. When it comes to financial computation, we need to have consensus on the processing between multiple locations. So taking a consensus constantly at multiple locations can be time-consuming. Omega square root of n over log bracket n. So N, using quantum internet, N is the number of players who need to have consensus among. So that's the number of players. But using quantum, that is always 1, which means that the time is very short. Time will be very short to get the consensus. When you are to avert accidents, AI may need to gain consensus, and that can be done on a real-time basis using quantum internet. So that may be another benefit. Next, on very long baseline radio telescope, the quantum sensor takes the data from the space, and we need 2 sensors to achieve this. And the current sensing technology is doing well. We are getting about 100 radio waves, but using quantum internet, we only need 10. If it goes well, then we can know the size of the terrestrial bodies in long distance. And we can also look into the ground instead of into the space or skies. And then we might be able to predict the signs of natural disasters. And we might be able to use this to look into our bodies to find out what's happening in our body. So there may be some opportunities to collaborate using quantum sensing technology. So this will be further advanced and developed in the future. So quantum internet milestones. First, quantum signals are transmitted into fiber. That was possible. So the single photon is encoded and transmitted, but the quantum signal is relayed and communicated. That is the challenge. Currently, the radio wave is now transmitted through Wi-Fi and expanded. And using quantum technology, that was difficult. But now quantum technology is being advanced, and quantum signal relay proof of concept is now successful in some laboratories. That is why we are trying to connect them, and the momentum is gaining to successfully implement quantum internet. And number 4 is the quantum computer structure. If we form this topology, then routing will be necessary. So quantum internet system will be established then, and once it becomes robust, and then we can form an even bigger network. So today, our vision of the finished product, we have 4 nodes. We have end nodes, and then in the middle we have the relay node, and this has the routing function. And if you look closely, you can see this is the quantum computing illustration, quite similar to that. So we are just connecting the quantum computers. In case of classical internet, we have the electronics, optics, and then network engineering and software engineering are on top. Then infrastructure and the application were there. But in case of the quantum internet, we have quantum informatics, quantum mechanics. So that is the difference. And at the bottom, we have the interface between photons. And that kind of research will need to take place. And the layer above, it is the quantum PCI-PC. So multiple nodes will be connected. More than 1 million quantum computers will have to be connected. So architecture-related research will be taking place. And using such internet, the arbitrary nodes will be connected to applications. So use case research will be implemented as well. And quantum internet theory will be formed. And we have the testbed for the lab area network. the distributed computer network is now researched in the Moonshot project, which will be expanded to Keio campus, which is about 200 kilometers away. And then in the future, other university campuses will be connected as well. And the real testbed, we can establish hardware. However, we need to simulate and understand whether it is really scalable. So these are the two important pillars. So this is about the Moonshot project. We are creating distributed computers, and then the quantum internet will be formed in the end. In the Moonshot project, I'm sure that many people are creating various quantum computers, and our responsibility is to connect these quantum computers. To summarize, quantum computer network enabling global transmission of quantum data and distributed quantum processing is the quantum internet. And application research. Quantum computer research was gaining momentum after the physical quantum computer was established. So just as the 2010s saw the beginning of the implementations of quantum computers, I believe that the 2020s will be the dawn of quantum network implementations. So I hope that you will be interested in what happens going forward in the quantum internet area. This is all from my side. Thank you very much for your attention.